The first type of energy we are going to calculate is kinetic energy. The equation is here to the right. It is 1/2 mv squared, and I've written it in two different ways to remind you that when I write v like this without a vector, that means speed. So this doesn't matter what the direction is. You would never put a positive or minus out in front. You can think of this as the magnitude of your velocity vector squared. So same thing, just clarifying the notation if you don't remember. K is a scalar. It doesn't have a direction, and in fact should never be negative. Negative kinetic energy doesn't mean anything. You can have a negative change in kinetic energy because that's a decrease, but you can't have a negative kinetic energy. As you can see, this depends on the speed and the mass. That is the hallmark of kinetic energy, is that it's depending on the speed. It does not depend on the position, and it doesn't depend on, for instance, the time. The units are joules, and in a separate video going through the notation, I talk a little more about that, but joules, or capital J, are the units we use for all energy, and so you're meeting that first with kinetic. Now, in a later video, I'm going to go through in much detail how to calculate work, because that's actually a very complicated concept. However, we can start by relating kinetic energy and work. One important thing to note is that this equation only holds true if we don't have any potential energy or other forces to think about. So in the situation where we have a single particle that we only are worrying about one external force, then we can say that the change in kinetic energy of that particle is equal to the work done. And our system, of course, is made up of that one particle. So this is true right now, but later we will be adding more pieces to this. So remember that work is done on your system by the external force. So we will be working on how to calculate work, but it's complicated. Anytime you have an increase in your kinetic energy, that your final kinetic energy is greater than your initial, that means that your object is speeding up. That means that your energy is increasing, and that means that positive work was done on your system. Vice versa, if your change in kinetic energy is negative, that means your object is slowing down. Again, this is change, not just value itself. That means it's slowing down, your energy is decreasing, and in fact you have done negative work. Negative work is the same idea as transferring energy out of your system. So one quick example before we learn how to calculate work is to look at this picture and think about a cannonball that is shot straight up. That initially it has some height and some velocity. Later, keeping in mind that we're not labeling t here, this is a before and after representation, later it's going slower. And this corresponds with your knowledge of things that go upwards slow down. And so if we calculate our kinetic energy, we see that our mass is the same, but our speed has decreased. This means that our kinetic energy has decreased, our change, and here I used Ke, should have used K, I apologize. Now work here is actually decreasing our energy, so we would say that work is negative, and work is going to be calculated based on the distance that the object traveled, the force, and then any sort of angular difference between the two, which will be discussed next.